Hello and welcome back. Today we are going to do 7.3 part 2. So this section is about similar triangles, and we learned about how to identify them. We learned about how to identify them in the last lesson. Today we are going to learn about applying what we know. So we are going to start off immediately with theorem 7.4, which is the properties of similarity. So the reflexive property says that a triangle is similar to itself. Symmetric property says that if triangle ABC is similar to triangle DEF, then triangle DEF must be similar to triangle ABC. And transitive, hopefully you know this one pretty well by now, how to predict what's going to happen. If ABC is similar to DEF and DEF is similar to XYZ, then ABC is similar to XYZ. For our first example here, we are going to be given the task to find two segments BE and AD. And here's our figure. Okay, these are all of the pieces of information that we are given. Hopefully you are able to see that we do have some similar triangles here. We can tell by angle, because we have all of these corresponding angles. So this is going to be angle A, it's going to be congruent to itself, and it works for both of them. Angle B is congruent to angle C, and angle E is congruent to angle D. And the reason for these two are they're corresponding angles. So we know that triangle ABE is similar to triangle ACD. Now we need to find BE and AD. So first I want to find them on my picture. What am I dealing with? Okay. So BE, I'm going to solve for X. And then AD is actually this entire stretch here. So I need to do more than just solving for Y. AD is actually Y plus 3. So let's just kind of write that down. BE is X and AD is 3 plus Y. Let's talk about some of the relationships that we know, since these are going to be similar. We know that AB and AC, the ratio, is going to be representative of the proportions of the triangle. And I intentionally picked that one first because when you look, you've got a lot of variables for all the other sides. AB over AC is actually the only one where we can get a real constant number very easily. So now we know that all of our proportions or our ratios have to be proportional to 3 over 5. This is going to make our lives a lot easier because I noticed that, okay, BE needs to be proportional to CD, And also AE needs to be proportional to AD. What this means is BE proportional to, or with a ratio to CD, that's going to be, I didn't really give myself enough space here. That's going to mean that BE is X over 3.5. So I need to make sure that ratio is equal to 3 over 5. And then AE over AD, that's going to be Y over Y plus 3, or 3 plus Y. Alright, so let's see what we can do here. We can solve for our variables by making proportions. I need just 2 proportions to be able to make all my variables disappear. So I'm going to start with this proportion right here. Cross multiply. Five x equals 3.5 times 3. When you divide by 5, you're going to get x equals 2.1, sorry. So that is what BE equals. Ta-da! 1 down. The next one is 3/5 has to be proportional to Y over Y plus 3. Alright, so we're going to do the same situation here. 5y equals, this is 3y plus 3. You'll be really sad if you don't distribute properly, so make sure you've got that under control. 5y equals 3y plus 9. Subtract 3y. And you get 2y equals 9. Divide by 2, divide by 2, y equals 4.5. Now, y equals 4.5 is not my answer, so wait. I need to plug it back in to AD here. So AD is going to be 4.5 plus 3, which is 7.5. So I have AD and BE now. Alright, I'm gonna give you one of these to try because I think you've got a handle on this. So find WR and RT. That's going to be your goal. So to do that, we're going to have to solve for X. And you can probably guess we are going to be needing to create a proportion. So the important thing that you have to start out with is what are your corresponding sides? What sides are going to form the ratios? So go ahead and pause. So you should get WR equals 8 and RT equals 10. So if you have any questions, make sure you star that and I can talk with you about them tomorrow. And this is actually a pretty short lesson because we've got just like one more example here, and it's a real world one. So, example 5, indirect measurement. Here we go. Alright, so our friend Hallie here is super into math, we can see, because she carries a measuring tape in her pocket. And she measured that her shadow is 3 feet long and the roller coaster shadow is 40 feet long. And she says, I want to know how high that roller coaster is. And of course her phone is dead. You know, all of those details that make this situation exist, all right? We have all of them in this real world scenario. So we've got a roller coaster and we want to figure out how tall it is. We have shadows that are going to be formed by the angles that the sunlight is making. So what we can assume in general is if there are shadows, assume similar. So you can assume that the triangles that they're making are going to be similar, because if you think about it, the roller coaster height is going to be a straight up and down with the ground. So we've got our right triangle there, and then we've got Hallie, who is also making a right triangle with her height to the ground. This is our shadow on the ground. Shadow. And the angle of the sun would be something like this. So that's why we are able to determine these are similar. Because these are similar, we just have to set up a proportion and we'll be all set. So we're going to want to have the shadows on the bottom. So 3 feet, and she's 5 feet 3 inches tall. Now, this is an interesting one. Do we want to leave it just like that? And the answer is no, because I don't have an easy way of multiplying by 5 feet 3 inches. What I'm going to do is say, okay, 3 inches is equal to 1/4 of a foot, since there's 12 inches in a foot. So I'm going to say that she's 5.25 feet tall instead of saying that she is 5 feet 3 inches. And because of the sunlight, it's the exact same time that we're measuring here, we know that that has to be proportional to the ratio of the shadow of the roller coaster and the roller coaster's height. So height on top, shadows on bottom. We go ahead and we multiply. We get 3x equals 210. Divide by 3, divide by 3, and I get x equals 70. So this roller coaster is 70 feet tall. All right, one more for you, and then we're all set. All right, give it a pause. And your answer should be 215 feet. All right, so tomorrow I think we're going to work a lot on word problems for these, for our practice problems for this. So be prepared for that. Maybe have some highlighters out for tomorrow so you can do some text coding. And I will see you then. Bye.